Hello everyone, in this video I'm going to discuss the example for vector. So kindly refers to the question, let the point P with the coordinate 1, 3, 2, coordinate for Q 3, -1, 6 and the coordinate for R 5, 2, 0 be the point in the three-dimensional space. Determine A, the direction cosine for the vector PQ. So number 1, we are going to find the vector PQ. So kindly refers to the formula vector PQ. So where we have vector PQ is equals to OQ minus OP. So kindly substitute the OQ and the OP. So here we have OQ 3, -1, 6 minus the OP where we have 1, 3, 2. So the vector for PQ is equals to 2, -4 and 4. So that is the vector for PQ. Next, what we have to do is to find the magnitude for PQ. So kindly refers to the situation where we have the magnitude for PQ is equals to square root of, kindly refers to the vector PQ where we have 2, -4 and 4. Kindly square the situation where we have 2 squared which is equals to 4 plus we have -4 squared which is equals to 16 plus 4 squared where we have another 16. So the magnitude for the vector PQ is equals to 6 because we have square root of 36 which is equals to 6. Next, kindly refers to the question direction cosine for the vector. So where we have cos alpha is equals to, we have 2 over 6. Then we have cos beta which is equals to -4 over 6. Finally, we have cos gamma which is equals to 4 over 6. So if we simplify the situation and we will have direction cosine for the vector PQ, cos alpha is equals to 1 over 3, cos beta is equals to -2 over 3, and cos gamma which is equals to 2 over 3. Kindly refers to the question B, whether the vector PQ and the vector PR are perpendicular vector. So previously we already determined what is the vector PQ. Now is the time to determine the vector PR. So given the situation, vector PR is equals to OR where we have 5, 2, 0 minus the vector OP where we have 1, 3 and 2. The vector PR is equals to 4, -1 and -2. Next, question asking about whether the two vectors are perpendicular vectors. So kindly refers to the situation where we know that we have to show PQ dot with PR. If the result equals to 0, meaning that they are perpendicular to each other. So now kindly refers to the situation where we have the vector PQ which is 2, -4 and 4. Dot, we have the vector PR where we have 4, -1, -2. So kindly dot the situation. So we have 8 plus with the 4 minus with the 8. So the vector PQ dot with the vector PR is equals to 4. So in here we notice that PQ dot with PR is not equals to 0. So from here we can say that the vector PQ and the vector PR are not perpendicular to each other. Or we can say they are not perpendicular vector. So that is the situation for B. So here we have the question C. Find the equation of a plane containing the PQR. So kindly refers to the situation where we have the formula R dot N is equals to A dot N. So first what we have to do is to find the normal, where we have PQ cross with the PR. So kindly fill up the vector. So where we have 2, -4, 4. So do remember, order is important. So 4, -1, -2. Next, we have I minus bracket J plus bracket K. Next, first, close up the I. So we have to cross the J and K. So in here, we notice that we have the situation which is 8 minus. So kindly cross this part and we will have -4. So in here we have plus 4. So from here we have 12I. Continue. Next is to find the J. So kindly close up the J. So next we have to cross the situation I cross with the k. So in here we have -4 minus, so kindly cross this part and we will have 16. So in here we have -16, then we will have positive 20j. Finally, in order to determine the k, kindly close up the k. So what we have to do is to cross I with the j. So in here we have -2 plus with 16. So finally, we have the situation 12i plus with 20j and then plus with 14k. So that is what we call the normal for the vector PQ cross PR. So here we have the normal. So kindly substitute the situation into the formula where we have r dot n is equals to a dot n. So in here r we have x, y and z. Dot with the normal where we have 12, 20 and 14 equals to a refers to the point where we have the point P or the Q or the R. So in here my suggestion is substitute 1, 3, 2. Dot with the normal 12, 20 and 14. So here we have the vector equation of a plane. If the question asks us to express the situation in Cartesian form, so our answer would be 12x plus 20y plus 14z equals to, so kindly dot the situation on the right hand side where we have 12 plus with the 60 plus with the 28 and finally we have the answer 100. So do remember to simplify the situation. So we divide the situation by 2. So finally we have the equation of the plane, which is 6x plus 10y plus 7z equals to 50. So that is a situation for C. D. We have parametric equation of the line passing through the point B, where we have the point B 0, 1, 2, and the equation of the line perpendicular to the plane C. So meaning that we are using the normal. So kindly state the formula. We have R is equals to A plus with the TV. So in here we need a point where we have the point B 0, 1, 2. Next we are going to find the direction. So as we can see in here, they said the equation of the line passing through the point, and also the equation of the line is perpendicular to the plane in part C. So means that we are going to use the normal. So kindly substitute the situation. So here we have x, y and z for R equals to A, where we have 0, 1 and 2 plus with t multiplied with the direction. So in here is the normal of the plane. So here we have the vector equation. Next, kindly refers to the question. The question asks us to represent the situation in parametric equation of a line. So x is equals to 12t, y is equals to 1 plus 20t. Finally, z is equals to 2 plus with the 14t. So that is the parametric equation of a line that passing through the point B and also perpendicular to the plane in part C. Thank you so much for watching this video. If you think the video is useful, kindly consider to like, comment, share and subscribe.